This is Unit 1, Lesson 1. Unit 1 is inequalities and absolute value function graphs, and in Lesson 1 we're going to be working on set builder and interval notation. Both of these things you should have seen before, so this is a little bit more of a refresher. All right, by the end of the lesson you should be able to define a set of numbers using set builder notation and define a set of numbers using interval notation and know the difference between those two. Okay, let's get started. All right, so remember that a set is a collection of unique elements. Elements in a set do not repeat. So we're saying a collection of numbers. Okay, whether it be looking at something is brought as a set of all real numbers, or something smaller by just looking at positive values between 1 and 10. Sets may be described by roster, by set builder notation, interval notation, graphing on a number line, and or a Venn diagram. So those are all different ways that we can use to represent and define what a set is, okay, a set of numbers. So we're going to start just by looking, as I said, at our set builder and interval notation. Okay, so set builder notation is this notation right over here that uses all this funky different looking symbols, and we'll go over what everything means. Okay, remember math is a language, so this right here is math language, so we can read that and translate that to English language. So taking a look, what this says right here is it's telling me that x is an element of the integers such that x falls between 2 and 6. Okay, we can also say 2 is less than or equal to x, which is less than or equal to 6. All right, so some things to be aware of. These right up here are symbols to represent specific sets of numbers. So when we say that capital R, it's saying real numbers. A real number is anything from negative infinity all the way up to positive infinity, including decimals, fractions, repeating decimals, irrational numbers, positives and negatives. Okay? Integers is a subset of real numbers. Okay, integers include your positive and negative whole numbers, -5, -4, +1,000,000, 0, but it will not include anything in between the whole numbers, so no decimals or fractions. And then we can say natural numbers is a smaller subset of integers. Those are your positive whole numbers, 1, 2, 3, 4, 5, 6, etc. going up. Okay, so if you see R, Z, and N, it's just representing the numbers, the specific sets. Okay, and as we look down here, we said, okay, so we're starting to introduce some different looking symbols here. This funky looking E, it's kind of just like a little loop in the middle. That is read as is an element of. Okay, so when you see that, you're saying X or whatever variable I'm looking at is an element of what bigger set? Are we looking at all real numbers? Are we looking at just integers? It makes a difference. Okay, in this example, we said Z was integers, and this line here, it's not a number one, it's a line. It's read such that. Okay, so once again, the statement says all X that are elements of the set of integers such that X is between 2 and 6 inclusive. All right, inclusive means because, hey, we're including 2 and 6 because I see a less than or equal to. So X can be anything from 2 to 6. Now, because this is the set of integers, the only numbers that are represented really here are 2, 3, 4, 5, and 6. Keep in mind, if I change that Z to an R, I'm opening up a world of possibilities here. I'm also including 2.1234, 2.99999. Okay, I'm including those decimals in there because they are real numbers. So I have an infinite possible solutions. Versus since I'm just looking at integers, I only have 5 different numbers that classify and fall into that set. All right, looking at our next one, you read this as all X that are elements of the set of integers such that the X values are greater than 0. Okay, so it's saying all integers greater than 0, which is also just your natural numbers. All right, sometimes you'll see a colon in there instead of the line. Usually we have that line, but just so you know that if you see a colon, it can also mean such that. So it's important to know what's going on here when you're looking at these symbols. Okay, it's important to know what's the big set am I looking at, real or integers or smaller things, and then what values are included. All right, so take a look down here, and it's kind of what I had touched upon a minute ago. When I look at this, take a second and try to read these to yourself. Pause the screen if you need to. All right, but our first one is read that all the X that are in that are elements of the set of integers such that x is between 4 and 30 inclusive. My second example is all the x that are elements of the set of real numbers such that the x values fall between 4 and 30 inclusive. So everything looks the same except for my real and my integer set. Okay, so remember what this one is showing you. If I'm looking on a number line, I'm not going to number all the way. Okay, but let's just start off 4, 5, 6, dot, 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 up to 30. It's saying, okay, I have the numbers 4, 5, 6, 7, 8, all the way up to 30. If I'm doing real numbers, it's including everything in between. Okay, it's not just the integers, it's everything all the way from 40 up to 30. So all of those decimals and everything in between, fractions, they're included. So it's just to know, make sure you're reading carefully and looking at what the parameters are. Okay, so interval notation. So set builder notation is when you're using, your brackets, you're using the X, you're using the element symbol, you're defining which set I'm looking at, I'm using that such that. Interval notation is really when we're just using parentheses and brackets, okay? It's another way to express our answers and our set that we're looking at as opposed to using an inequality. Because if you notice back here in our set builder notation, everything was an inequality after all that fancy jargon. Okay, 2 is less than or equal to x less than or equal to 6. X is greater than 0. 4 is less than or equal to x less than or equal to 30. That's kind of like the rule, the numbers that we're looking at. When we're talking in interval notation, we're always going to assume we are working with the real numbers unless you are specifically told otherwise. So once again, for interval notation, because there's not a place to really put it in the notation, it has to be specified. So for now, we're going to assume it's always the real numbers, okay? So what you need to know is the difference. When you have just a parentheses right here, it's telling you that it's not included or it's open. A bracket means the number is included or closed. Okay, whenever we're thinking inequalities, less than or equal to is less than, you've got to know which one's telling you included, which one's not included, and all that good stuff. Okay, so looking at this example over here, this is 2 is less than or equal to x, which is less than 6. That's how it's represented as an inequality. As an interval notation, it looks like this. Okay, because the 2 has a less than or equal to next to it, it's getting the bracket. It is included. Okay, I kind of think of it because the bracket's kind of like half of a capital I for included. That helps me remember, hey, brackets included. Just a thought. All right, and since the 6 has just a less than, there's no equal to, I'm sorry, greater than when you're looking backwards, it's going to be an open, not included. All right, and you should have been exposed to them in previous math courses, but if not, that's okay. So if I'm looking at just kind of go over a few quick examples here. If I'm looking from 3 to 7, notice both of my inequality symbols do not have equal to's. So I can use a parenthesis for both. That would be interval notation. Okay. If I'm going from 5 is less than x, which is less than or equal to 10, the 5 gets a parenthesis, the 10, because it's included, gets a bracket. All right, or 9 less than or equal to x less than or equal to 22. Both of them have equal to, so both get brackets. All right, so our directions say use a description to graph the set of numbers on a number line and then write the set in interval notation. Okay, so let's first over here under the description, let's write an inequality also. Okay, no, the directions don't say to do that, but let's go ahead and do that. So our first example says the set of all real numbers between 1 and 5. Does it tell me to include 1 and 5? No, it's saying between, and there's nothing in there that's indicating that 1 and 5 will be choices. So if I'm going to write that as an inequality, this is what I have. 1 is less than x, which is less than 5. Okay, now to put it in set builder notation, remember it didn't ask me to, but we draw brackets. X is an element of real numbers such that, okay, that's how we're doing in set builder notation. We're taking that inequality and we're putting the fancy notation around it. All right, so graph it on a number line. Think way back to your middle school days. 1, 2, 3, 4, 5. Since, skip the 4, since 1 and 5 are not included, we of course indicate that with our open circle, and then we're shading between the two. Okay? To write in interval notation, 1 comma 5. Parentheses, because it's not 1 and 5 are not included. Our next example says the set of all real numbers from 1 to 5 inclusive. So we're pretty much doing the same exact thing, except we're going to go ahead and add an equal to sign on there. Same thing if I want to put it in set builder notation, x is an element of the reals, such that the brackets. So now this time when I go to my number line, 1, 2, 3, 4, I keep skipping 4, huh? I'm going to do a closed circle. I'm shading it in because it's telling me that everything that's shaded is represented and 1 and 5 are shaded as well. So when I put it into interval notation, I use brackets, not parentheses. All right, the set of all real numbers greater than 1 and less than or equal to 5. So x is in the middle, greater than 1, less than or equal to 5. Okay, I'm going to skip the set builder notation for now. You can go ahead and add those x's and elements and r's in on your own. So from here to here, going from 1 to 5, got an open circle, got a closed circle, shade in between. Now I put in interval notation, 1 comma 5 with a bracket. Pardon me. The set of all real numbers greater than or equal to 1 and less than 5. So just making sure you're reading carefully. Okay, so going from 1 to 5. This time this 1 is my closed circle, 5 is open, shade in between. 1 gets the bracket, 5 gets the parenthesis. The set of all real numbers greater than or equal to 1. I only have one number in here, so x is greater than or equal to 1. So my number line, 1, closed circle, greater than, shaded this way. Okay, so in order to do interval notation, though, I need two numbers, I need two boundaries. So I'm going from 1 up to infinity. 1 gets a bracket. Infinity will always get a parenthesis, because remember, the bracket is telling you it's inclusive. Infinity is not technically a number, it's more of a boundary. It's telling you a direction you're headed. Infinity never ends. So I can't put a bracket on there because a bracket's indicating ending at that number with that number included. Well, I don't know what number is out there because it keeps going on forever and ever. So super important to remember that even though technically infinity is included, since itself is not a number, I can't put an end to it. It keeps going on forever and ever and ever. So infinity gets a parenthesis, non-inclusive. And our last example, the set of all real numbers less than or equal to 5. Okay, so we're doing going in the opposite direction. So my number line, got 5, shade. Okay, so 5, and 5 gets a bracket because it's included. Now, since I'm going to smaller numbers, I need to indicate the negative infinity. Okay, I don't have to put a positive here because it's implied. If you do it just for your, to help you remember, that's totally fine. When I'm moving down to negative infinity, I need to see that symbol, okay, because I need to indicate that I'm going towards my negative numbers. And also the parenthesis, once again, because it's infinity. All right, let's take a look at some more problems. All right, so for some intervals, it is necessary to use combinations of interval notations to achieve the desired set of numbers. All right, so consider how you express an interval, all numbers except for 13. Okay, all numbers except for 13. We can't just say it's everything but 13. Well, no, we can. That's what it's saying. Sorry, lost my train of thought there. But all right, so as an equality, we could represent it saying x is less than 13 or x is greater than 13. Okay, it's either this or it's that. It's on either side. In interval notation, we use this funky U. We write two separate interval notations, all right, and that U means union. Okay, union is for the word or. It's either going to fall in this interval or in this interval. All right, the next one says, consider expressing in interval notation the set of numbers which contains all numbers less than 0 and also all numbers greater than 2 but less than or equal to 10. Okay, so let's look at an inequality first. Okay, so the set of numbers contains all numbers less than 0, so x is less than 0, and all numbers greater than 2 but less than or equal to 10. So I've got two different situations here. All right, so I'm working with an or here. I know it's saying and in the problem, but you can't fall into both categories at the same time. So you're either less than 0 or you're going to fall between the 2 and the 10. All right, so make sure we're putting as an or because we're going to make this a union. Okay, so to represent the x is less than 0 as an interval notation, negative infinity up to 0. And 0 is not included, so we're going to go ahead and make that a parenthesis. Make our union symbol since we have two different situations. 2 is not included, so it gets a parentheses. 10 is, so it gets a bracket. Okay, so we're going to go ahead and go through and do just a couple small problems. Taking a look at this. All right, so number 1 says this number line graph would be best described by which statement? Okay, so let's just go ahead and take a look at what's happening here. We're going from -7 to -1 inclusive, and then from 3 not included up to 7. So I can write that as, I see my two choices are in inequality and an interval. So let's write them in both and see which matches. So I'm going from -7 to -1, and then from 3 to 7. All right, and then for over here, I can use brackets for both of those. And since I have two different things, make it a union and going from 3 with a parenthesis up to 7 with a bracket. So I notice both are given to me, so technically both answers are correct. All right, the second one, all numbers from negative infinity up to and including -4, as well as all numbers greater than +1. Okay, so I'm going from negative infinity up to and including -4. So here it is in interval notation, parenthesis and bracket. And then also all numbers greater than +1. Okay, so I'm going from greater than, it's not including, +1 up to infinity. Okay, so that would be my answer in interval notation. Okay, so to write an inequality, I'm going from negative infinity to -4. So I'm saying x is less than or equal to -4 because 4 was included. Sorry, -4 was included. And over here, I'm going x is greater than 1. So I've written it myself in inequality form and interval notation. Let's see which matches. So looking at the first choice, this one does not work because I have an equal to 1. Okay, we said it has to be greater than +1. The second choice does not work because it also has an equal to 1. It has a bracket there. My third choice written in set builder notation, that works because I don't have the equal to. And I just drew it in to show you this. It's not there. Okay, so that is my choice. Our next problem, all numbers from -3 up to and including +7. So going from -3 up to and including +7. It doesn't say anything about including the -3. Okay, so my choice here would be the middle guy because this one has my signs backwards as well as that one. All right, which statement below is the correct set builder notation? So look at where we're going. We're going from -9 included to -5. We're going from 0 all the way up. So we're saying x is greater than 0. So looking at my options, it is the first one. Which statement represents x does not equal 9. So it's going to be everything except for 9. All right, and in this case, all of the above work, okay? X is less than 9 or it's greater than 9, and that's what this tells us here. Or in set builder notation, we could just write the one exclusion. Okay, I could do that as opposed to an inequality. So all of them work. They all represent the numbers we are looking for. Number 6, how do you read this sentence? We're going from 3 to 5, but because 3 and 5 are included, we are going to say it's inclusive. And it can't be the last choice because if this was a Z, okay, if that was a Z, that would work, but it's not a Z, okay? Meaning it's not just a set of integers, so it can't just be 3, 4, and 5. It's including everything in between. So what's the difference between the number line graphs of these two intervals? Well, if we notice, 2 has a parenthesis, so 2 is not included. So we're looking for one that tells me that on my first graph, the 2 should be open and shaded while it's closed and shaded on the second graph. Choice A. All right, and finishing up the correct interval notation. I'm going from -9 included, so that should be a bracket, to 5 not included, which is a parenthesis, 0 up to infinity, so x is greater than 0. Okay, so 0 to positive infinity. Both of those should be parentheses because we have a positive infinity there, so that was our choice. And that concludes our lesson.